Um, Hello, welcome everybody. Uh, Welcome to the course in probability and statistics. We've already seen certain definitions, right, of what's a continuous probability distribution, what's a discrete probability distribution, and so on and so forth, right? So with this idea, let's uh, let's move forward and kind of take examples. Before going to examples, let's define certain things. Let's look at what is a distribution function or a cumulative um, probability function for a given. All right, so let's look at that. So um, so what we have is it's distribute distribution function, right? Distribution function, right? Uh, or it's also called as distribution function, or it's also called as cumulative probability function. It's called as cumulative probability. Cumulative probability function. Okay. So let's kind of look at what exactly this means. Okay. So suppose x is a random variable, discrete random variable. For suppose we'll look at the continuity property later. Okay. So if x is a random discrete variable, right, with probability function p of x, right, we say that with probability density function with PDF p of x, probability density function p of x, right, then the distribution, right, then the distribution, let's take probability, I'll just mention that the probability function with the probability function p of x, right, then the distribution function usually denoted by f of x, then the distribution function denoted by f of x, right, is defined as f of x equals to probability of the random variable x for which for all x which is less than or equal to x, right? That is if x takes integral values, say 1, 2, so on up till n, right, and so on, whatever, then what happens is f of x, right, so till up till n, some finite, right, I'm looking at that, right, then what would I get is then f of x, right, would be equal to p of at x equal to 1 plus p at x equal to 2 plus so on up till p at x equal to n, right, x equal to x rather, x equal to 1, x equal to 2, so on up till x equal to x, less than or equal to x, right? So yeah, I'll just wipe this out, just take x there instead of n, right, x, okay, this is capital X, just make a correction about that, right, which is equal to this is at p1, we have already seen that, this is at p2, so on up till this would be at p of x, right. Let's write down some remarks here. Okay, we'll calculate these things. Okay, what's the probability PDF and given PDF probability density function, how do you calculate the cumulative probability function? Okay, the first remark is what will happen to f of x minus 1? This would be equal to p1 plus p2 so up till plus px minus 1. Okay. Therefore, what happens is, therefore, if I kind of subtract f of x, right, minus f of x, right, sorry, f of x minus 1 rather, or would it be other way, f of x minus 1? Not really. Yeah, that's fine. F of x minus 1, what will happen is p1 will get cancelled with p1, p2 will get cancelled with p2, minus p2, minus p3, so until minus px minus 1 will get cancelled with minus px minus 1. What will be left? What will be left is this is equal to p of x, right? So let me name this as some star. Okay, right? Uh, therefore, if x is a random variable which can only take positive integral values, then probability function can be obtained from the distribution function by using star. Okay, so if x is a random variable, right, which can only take integral values, then the probability integral values, then the probability, probability function, right? Probability function can be obtained from a distribution function, from the distribution function using star, using star. Okay, right? So this is the case when when f is a discrete random variable, right? Random discrete variable. I missed m there. Okay. Now let's take the case. Let's look at the case rather when we have a continuous random variable. Okay. What does this mean, right? What does this mean? What does this mean, right? This kind of expression. So let's look at this one. This is part 2 of the remark. Okay. If x is a continuous, if 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 x is a continuous random variable, which can only take positive with probability density function, random variable with probability density function. It's PDF, right? Probability density function p of x, then the distribution function, right, is given by f of x, which is nothing but probability of all x which is less than or equal to x, right? So this is nothing but negative integral, integral from negative infinity to x, p of x. Or let me use some other variable here. So I'm using x in this context. Let me use some changed variable, t, right? Doesn't really make a difference because variable of integration is just dummy, right? That's what we know, right? It doesn't really matter. So with these ideas of what's a probability or cumulative distribution function and all those things, let's kind of look at some really interesting problems. Okay, right? It's not so difficult to find out these things with respect to discrete. It's pretty much straightforward. Okay, so let's take a very simple example. Okay, as follows, right? So what we are given is we are given a probability distribution for a random variable x, right? And we are given corresponding probability function, and we need to find all these probabilities, right? And first thing first, we need to find what is k, right? And then look at uh, what are the other things, right? So note that we need to note that, right? uh, we know that all this probability, if I add, right, is 1, isn't it? All these pi's, if I add 1, all the total probability has to be 1, right? Therefore what happens? P of 1 plus, rather, P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4, right, plus P5 plus P6 has to be 1, right? But what is this? This is 0 plus k plus 2k plus 2k plus 3k plus probably 5 is k square plus 7k square plus k is 1, right? So therefore what do we get? This is 3k, 5k, 8k, right? 9k, right? This will be 9k plus this would be 7 plus 8, right? Plus 8k squared equals 1. Therefore, what do I get? 8k squared plus 9k minus 1 equals 0. That's precisely what we have, right? Therefore, uh, what do we get? If this is kind of a quadratic equation, and how do I solve for k? You know that the formula is equal to minus b plus or minus square root of b square minus 4ac over 2a, right? So what is minus? Minus of b, so this is minus 9 plus or minus squared of 9 square, that's 81, right? Negative, I hope you know that that's the thing, right? And well, I don't know, this might be a bit difficult. Let's check out. And it's 4 into 8, right? 4ac, so this would be plus, right? 4 into 8, that's 32, right? If I'm not wrong. Well, that must be something which um, kind of should be very careful. I should be very careful. Because I would be getting something in root, right? That may not be nice to kind of work with. Okay, so what we can do? Rather, I thought maybe uh, this kind of gives me, but what will happen is it will kind of give me something pretty bad, you know. So I want to be in nice things. So uh, what I want is just a small change. I hope just because I don't want to work in square root, because I can actually work, but then that's not what I wish for, right? So well, what I can do is I can just make a modification. um, Instead of I want it to be 10, right? So just the modification I'm doing, right? Uh, right, so just a modification. I hope you kind of bear with me. Let me just take this to be 3, right? And then I'm all done. So what will happen is this is 3k square, right? So I hope you can just kind of modify. Just the only thing is I don't want to be in square root, you know, right? That's the only difficulty I would have. So now this would be 3k, so this will be 10k, and this would be whatever we had, right? K plus it's 5, 6, 7. So this would be since I've just changed this would be yeah, this would be 8 into what I was saying, 10, right? So I just made a mistake. So just kind of this is 40, right? We have taken this to be 40. Oh man, supposed to be 10. What am I doing? So this is 10, right? So now this would be 40, right? Over 10, isn't it? So this comes out to be minus negative plus or minus square root of this would be 121, right? Over 10. So this would be square root of 121 is 11, right? So this would be minus 9 plus or negative 11 over 10, right? So this will have probably two roots, right? So k can be equal to negative 9 minus 11 over 10, or k can be negative 9 plus 11 over 10. So this means k can be negative this would be 20, right? So negative 2, or k can be, this would be what, 2 over 10, which would be 1 over 5, right? But we know that k is positive, right? Uh, right, the thing is k is positive, isn't it? So therefore what would we get is, therefore if k becomes negative, then I will never get this to be wait look at this k to be, yeah, what I have is, but let's write down that, but k is greater than 0. This would imply that k is 1 over 5. I think I did a mistake here. Generally do that in calculation. This must be 2 times 10, right? So this is 2 times 10. So this would be negative 1. I'm sorry, slight amount of mistake, right? This would be negative 1, right? This is 2a, right? So this is 2 times, I'm sorry about that. Or this would 2 would get cancelled, and it's not minus 1 by this is 1 by, sorry about that. Generally do this error 1 over 10, right? But k is positive, right? K cannot be negative. So what I would get is, this is 1 over 10, right? Uh, so that's what we have. K is negative 1, or k is negative 1, or k is 1 over 10, but k is positive, right? So what we have is k to be 1 over 10. Therefore what would happen is, therefore the second, so for the first question is the answer to the first question is k is 1 over 10, right? Now we can look at what is the second question. We need to find probability of all x less than 6. What is this? This is like probability of 0 plus probability of 1 plus probability of 2 plus probability of 3 plus probability of 4, right, plus probability of 5, right? So this would be what? This would be equal to 0 is 0, right? P of 1 is given to be k, right? That's 1 over 10, plus this is 2 over 10 plus p over 3 is, wait a second, let's just look at table. 0 is p p less than 6, right? Wait a second, p greater than or equal to 5. Let me just change, I have done some error while giving the question also, man. Yeah, okay, that makes no difference. Well, and then just let me change the question here. Instead of 0, let me just take 1. Because there was supposed to be another table here. I'm just taking 6 numbers. In question there's 7 possibilities. I've just modified the question. That's the only difference. Okay. So okay, so in that case what I would get is till 5, right? So this would be 1 over 10, 2 over 10, right? Then this would be again 2 over 10, right? This will be again 2 over 10, 2 over 10, right? So this is 0, this is 1 over 10, 2 over 10, 2 over 10. What is P4? P4 is P4 is um, 3 over 10, that's taken. No, so this P4 is 3 over 10 plus P5, right? P5 would be k squared, so 3 over 10 squared. This is 3 over 10 squared. If my calculations are pretty much correct, right? So if that's the case, what I would I get? Let's check out. This would be equal to, the LCM is 10 squared, so multiply this. This is 0 anyway, so this would be 10 squared, so I have to multiply by 10 plus 20 plus 30, isn't it? I hope I'm not making a mistake. This is the 10, 20, 20 again, 10, 20, 20 plus 30 plus 3 over 100. So the denominator is 10 square, so I have to make a common denominator. 10 square is 100, right? So if I want to make common denominator, I have to multiply by 10, 10, 10, 10 throughout. I hope you know how to make a common denominator. This will be 10, 20, 20, 30, and 3, because it already have 10 square in the, in the denominator. So this will be 50, 80, 83 over 100, right? P less than 6 is, what about P greater than 5? Well, if you want to calculate P greater than 5, right, let's look at that. P x of greater than or equal to 5, if I'm not wrong, right? Greater than equal to 5. So this would be equal to P5, right, plus P6, isn't it? So that can be calculated. What would be P5? P5, I've already seen that it's 3 over 100, right? 3 over 100, or 3 over 10 square rather, plus this would be it's 7k square, right? 7k square. So let's look at this one. 7 over 100 plus 7k square plus k, right? So this will be plus 1 over 10, if I'm not wrong. Okay, right. So again, multiply and divide by 10 for this to make it 100. So this is 10 plus 10, right? That's 20 over 100. This is 20 over 100, right? So you can look at this as 1 over 5. Yeah, that's what we have, right? P of 2. Then third one is, what's P greater than equal to 5 is done. P1 less than x less than 5. Okay, how can we calculate that? Okay, that's pretty simple, right? This would be P of 1 less than x less than 5 would be P of 2 plus P of 3 plus P of 4, right? X can be 2, 3, and 4 because it has to be less than 5. So what do I get in that case? Okay, so 1, 2, 3, 4, right? So 1 by 10, 2 by 10, 2 by 10, and 3 by 10. So 2 by 10, let me just check. 2 by 10 and 3 by 10. So 2 by 10, 2 by 10, 3 by 10, right? So that comes out to be denominator the same, that is 10, right? This is 2 plus 2, 4, 4 plus 3, 7, right? Right, that's the answer, right? So this is how this was some very simple problem. Okay, let's take up some more kind of complicated problems in which we'll have to look at again discrete probability distribution. We would take continuous, we can take a bit later. Okay, right. What we would take is another problem. We'll see. Okay. Okay, so let's look at more examples. uh, we are still in probability uh, regarding the discrete random variable, right? Probability distribution of okay, I'm just taking those kind of examples. So another example here, example. Uh, Suppose two cards are drawn randomly. Okay, first one, right, successively, right, with replacement, and B is simultaneously, right? That is successively without replacement, right? From a well shuffled, from a well shuffled, well, um, well shuffled um, pack of 52 cards, right? What we need to do is find the probability, find the probability of number of aces, find the probability, find the probability of the number of aces. Okay, so we need to find probability of number of aces in both the cases, right? So let's do this solution. Okay, so let's fix our random variable. Let x denote, right, the number of aces, obtained in a draw, of two cards, right? Therefore, x is a random variable, right, which can take values. So what are the values I can get when I take two cards? What are the possibilities I'll be picking up aces, right? One is both the cards are not aces. One of them is ace, or both are there. Both of them are aces, right? Uh, right. So let's look at this one. No, note that probability of drawing an ace, right, is 4 over 52, right? That's something 1 over 13, right? If I'm not wrong. And probability of drawing a non-ace. If probability of drawing an ace is 1 by 13, then probability of drawing a non-ace is equal to subtract that the probability of drawing ace. It's like a complement, right? So sample space is 1, probability of a sample. By the way, got to prove these things. Probability of a sample space is 1. Please prove this. Then if A is a subset of sample space, then probability of A is less than or equal to probability of S, which is 1, right? Please prove this. Then if A is a subset of B, then probability of, and both are subset of S rather, and probability of A is less than or equal to probability of B. Please kindly then also prove that probability of empty set is 0. So these are the things I would please leave it to y'all. I've not done this, but these are simple results. Please kindly help yourself in kind of doing this. Okay. So this is what we have, right? And also I think I have proved this probability of A plus probability of A complement is is kind of 1, right? So well, for any event, right? You just look at the total probability, subtract, this is like a complement event to this. So what would be this? This would be this is 13, by the way. This would be 12 over 13, right? Okay. So since the cards, right, are drawn with the replacement, right, therefore all events are independent, right, therefore all the draws, right, draws are independent in the all the draws are independent, right? So what do we have? What do we have? Therefore, probability of both the aces, like random variable is 2, right? The value for the random variable is 2. That is picking up right, ace and ace. That's probability of first draw is ace and ace, right? That would be equal to that's probability of ace again with probability of ace, because these are independent, right? So it's just multiplication, right? Probability of ace into ace. But this is like 1 over 13, right? Multiplied by 1 over 13. So this is 1 over 169. Okay. Therefore, what is P of x equal to 1? That's probability of ace and probability of ace and non-ace, right? Non-ace. This would be equal to, again, these are independent, right? Probability of ace and probability of non-ace is independent event. So this is probability of something which is an ace multiplied by probability of non-ace, right? This is 1 over 13, this is 12 over 13, so this comes out to be 1 over, sorry, 12 over 169, okay. And the final one would be probability and probability that both also and finally what would be happen for probability that none of them is probability of non-ace and not, but you can directly do this, you just subtract this, but then let's do that. Probability of both are not aces means you subtract one minus probability that both are aces, right? Because these are complementary, both are ace and none of them is ace, are complementary. uh, non-ace, but we'll do this, is probability of non-ace, right, multiplied by probability of non-ace, right? uh, you can do that other way also, but let's I'm doing this way, subtract one or whatever this is. So this is like 12 over 169, if I'm not wrong, right? Multiplied by 12 over 169, right? Then what I would get, am I doing a mistake somewhere? Probability that first one is ace and second one is non-ace, right? So I'll have to add one more. Oh, I did a mistake here. See, I generally do a mistake, but anyway, let's kind of finish on this. This is 144, right? This is 144, right? This is 144 over 169. Wait, none of them is ace. No, I can't do that. Both are aces. Anyway, we would do this way. And here I did a mistake because I should have taken, let me just correct that, because the first one, if it's an ace, this will be 1 over 13 into 12 over 13, right? Plus here it will be probability of non-ace, right? Multiplied by probability of ace, right? So this is plus 12 over 13 and multiplied by 1 over 13. So this comes out to be 12 plus 12, that's 24 over 169. So I generally do this kind of mistakes. Make sure that you kind of keep your eyes open, right? So therefore I get the probability distribution, right? You get the probability distribution. What are the possibilities? Therefore the probability distribution, therefore the probability distribution of x is, I can draw the table, nice table, right? Yeah, let's go to that. So what do we have? We have x here and then we have p of x here. So it's 0, 1, 2. When it's 0, it's 144 over 169. When it's 1, it is 24 over 169. And when it is 2, that's 1 over 169, right? So That's the probability distribution of the random variable, right? Now, this is about when the replacement is allowed, right? You are replacing the card. What if there's no replacement, right? So without replacement. So if the cards are drawn, right, without without replacements, without a replacement, right? Then the exhaustive number of cases, then the exhaustive um, number of cases, right? Exhaustive number of cases of drawing two cards, uh, of drawing, right, two cards out of 52, right, is how many ways I can draw two cards from 52? That's 52C2, right? Isn't it? Therefore, what will I get? Probability that I'm picking up no aces, right? That is probability that there's no ace in both the draws, right? That means this is same as probability that both are non aces, right? So uh, what would be this probability that both are non-aces, right? That means you remove the four aces, right? And then look at both the I mean, uh, both are, what should you get is you should get non-aces, right? So what, out of 52, right? When would I get no aces? When I just remove aces and keep it aside and then draw, right? So what would I get? What would I get? This will be 48 cards which will be left. I'm removing all possible aces, and keeping it aside and then drawing. So this would be 48C2, right? So if I do this, I will get no aces here, right? This is a total favorable outcomes, right? And to the event that there are no aces. And the total number of outcomes would be 52C2, isn't it? That's a probability, right? So this comes out to be, check, this is 48 into 47, because 48 into 47, 46 factorial will get cancelled, and 2 factorial will get cancelled here, so I'm not writing that. And this is 52 into 51 because 50 factorial will get cancelled. And if I do a little bit calculation here, what comes out to be is 188 over 221. Just check my calculation. Most of the time the calculations, I would without even guessing, no second guessing, I would falter. So just make sure that the calculations, whatever calculations I'm doing, are pretty much checked out by you. Now when I'm putting x equal to 1, that is probability that 1 is, right, I'm picking up at least one ace. This would be equal to probability that it's one ace, right, and one non-ace, right? So what would be this? This would be equal to, when I pick one ace, how many ways I can pick one ace, right? This would be 4C1 ways, right? Picking up one ace, right? How many ways I can pick one ace, right? Total aces are 4. I can pick one ace as into 4C1 multiplied by how many ways I can pick one non-ace, right? One non-ace can be picked. There are 48 non-aces, right? So I can pick them in 48C1, right? I hope you are getting what's ace and what's non-ace, right? And the total cards are 52C2. So this is 4 into 48, right? Over this would be 52 into 51, right, over 2. So if you look at the calculations, this is cancels out, and all this calculation would lead me to, just check out, um, uh, well, it looks like I would be landing up in 32 into 221. Just again, uh, be sure that you check out my calculation, okay? um, so this is 32 over 221, and the last one is probability that x is 2, right? That is probability of both aces, right? Probability that both are aces. Therefore I can choose both aces, like, right, in 4C2. So the total ways I can choose two kings, right? Isn't it two kings, uh, right? The total ways I can choose two aces, right? Is 4c2, and I'm choosing from 52 c2. So if I do a little bit of calculation, this comes out to be somewhere around, 4 3, and this would be 52 into 51. So if I do some calculation here and there, it comes out to 1 over 221. This you can check my calculations. I'm not um, too sure whether the calculations are correct. Okay, so be careful. You know, sometimes I do tend to make a mistake. You know, so let's write the probability distribution of x when the shuffle, the replacement is not allowed. So the probability distribution of x would be, um, how would I get that, right? I would do that. So the probability distribution of x would be, here it is x, here it is p of x. Let's write down. When it is 0, 1, and 2. When it is 0, this comes out to be something around, if I'm not wrong, 188 over 221. When it is 1, right, 1, 1, it comes out to be 1 is 1, non is, it is just 1 is, it comes out to be 32 over 221, and the last one is 1 over. These are the three things, right? Three kind of the probability distribution of the random variable x. When you're saying that the replacement is not allowed, right? That's the idea. All right. That's another problem quickly. I kind of yeah, give you some problems for you to work out. These things are not difficult. So I can leave at least two, three examples for you all, right? I'm just doing one more, and then I can leave two examples for exercise, right? So I hope you are kind of following what things are. If you have any doubts, please feel free to message me whenever you need any kind of clarification on whatever I do in the video, right? So let's take another example here, right? Example. Um, so what it is asked is, I need to obtain the probability distribution for number of uh, sixes, right? In a tossing of a die, right? Obtain the probability, obtain the probability distribution, the number of sixes of the number of sixes, right? In two tosses of it, in two tosses of a dice. Well, solution is simple. Let's name the random variable, right? Let x be the random variable, random variable, let x be the random variable, um, which denotes, which denotes the number of time six appears, right? Okay, the number of sixes, the number of sixes, right? In two tosses of a die, in two tosses of dice, right? So what therefore x can take values, right? When I take two tosses, what might happen is I can get no 6, 1 6, or both the time 6, right? So these are the possible values. Let us write down. Uh, note that note that probability of getting a 6 6, right, is equal to 1 over 6, right? And probability of getting a number which is not 6, getting a non 6, or probability of not getting, rather, not getting a 6, right, would be 5, right? 5 are the numbers which are not equal to 6, right? So therefore, let's write down probability of x is equal to 2, right? That is probability of getting a 6, right, and 6, right, would be equal to 1 over 6, right, into, clear, right, that would be equal to 1 over, right? That's probability of x equal to 1, that is probability of getting a 6 and non 6, not getting a 6, right? That would be what? That would be 1 over 6, right, isn't it, into 5 over 6, right? So I'm not writing this, but I hope you can get this. So probability of getting a 6 and a non 6 is this probability of getting a 6 here into probability of getting a non 6 here plus probability of getting a non 6 here plus into, sorry, rather, probability of getting a 6. I hope that the part would be multiplied by 1 by 6. So this is like 5 plus 5 over 36, right? That's 10 over 36, right? And the final one is probability, right, of getting both equal to 6, probability of, oh sorry, not getting probability of not getting it, that would be 0 here, right? So that is what we have is probability of not getting 6 and 6 and probability of not getting 6. That would be what? 5 over 6 something. That would be 25. So if I draw the table of probability distribution of this random, this kind of random variable, right? Then what do I have? Let's kind of we draw that. Um, and then see. So bring this here, you know, and this, right, so that we can write whatever we want inside this. Write down bigger table, bigger and better. So what is this? Is nothing but manual use. This is my x. This is my p of x. What are the values? This is 0, 1, 2. What is when x is 0? It's a probability. It is what we was getting is 1 over 36. Here it is 10 over 36, right? And right, and this is 25. It's all about the probability distributions of all the um, this of the that's the idea. Can give you all problems. This is all about discrete random variables. Next time we'll check out if that continuous problems on continuous random variables. How do we check and how do we so exercise? I'll leave it. Please kind of finish this. Obtain first problem. Obtain a obtain the probability distribution. Careful when you do this. You got to take all the cases, right, of number of hits. Number of hits. Number of hits, right? In two tosses of a coin. In two tosses of a coin. Okay. And the second one is five mangoes. Five mangoes are accidentally um, right, um, mixed with 20 good mixed with 20 good apples once, sorry, and by looking at them, it's very difficult, right? It is not possible to differentiate between to differentiate between very difficult to differentiate between them. Four mangoes, four mangoes, right, are chosen or drawn, right, at a at at random from the lot. Okay, find probability distribution, right? The probability distribution, probability distribution of x, right? Where x is the number of effective mangoes, right? Effective number of mangoes. Finally, do this. Come back next time with the problems on continuous uh, probability distribution. Till then, thank you. Thanks a lot.